MacMaths, MacMaths, let's do some maths today. MacMaths. Okay guys, so today we're going to look at exercise 10b. I've drawn a couple of triangles for you already and ready for this, and it's in the textbook, but I just thought I'd go through and make sure I explain this to you so you understand it fully and how it applies to angles. So today we're looking at exact values of common angles, and those common angles being 30, 60 and 45 degrees. I hope you're able to sort of get on and work and take your mind off things. We've been taking our mind off it. We've had family games. We played board games last night, so that helped to take our mind off things. There we go, that's what we played last night. But yeah, you've got to keep busy in these difficult times, haven't you? Okay, going through the triangles, and I've set these up. I've actually written out, which aren't in the book, but I've written out the basic trigonometry ratios from GCSE. So sine is the opposite over hypotenuse, cos adjacent over hypotenuse, and tan opposite over adjacent. If you remember, they apply to right angle triangles. Okay, so if we take an equilateral triangle, and the only reason I've taken an equilateral triangle is because, of course, it gives us the angle of 60 degrees. And if I drop down a line of symmetry down the centre, it creates 90 degrees there, and of course at the top then it will create also the angle of 30 degrees, and that's one of the ones we're looking for. We've got 60 degrees, and then you can see on this triangle, this right angle triangle here, if these two sides are the same length, okay, it creates an isosceles triangle, and of course this will be 45, 45 and 90. Okay, so we've got all the angles that we want now. We just need to work out the ratios. Okay, so we'll do the 45 degree first. If we call this side 1 for convenience, then this side would be a length of 1 as well. And then the hypotenuse, using Pythagoras, 1 squared plus 1 squared square rooted, would be the square root of 2. Okay, so now that means that if we want the sine of 45 degrees, the sine is opposite over hypotenuse, so 1 over root 2. So the sine of 45 is 1 over root 2. And that's an exact value, okay, that we use in surd form for the sine of 45 degrees. Okay, your calculators will give you that as well. If you did put in the sine of 45, it will give you 1 over root 2. It will give you the value in this surd form. We can rationalise that if we want. Okay, we can times top and bottom by root 2 and get it as root 2 over 2. But, you know, I know we do that at AS, but mathematicians usually just leave it as 1 over root 2, unrationalised. Okay, so if we do the cos of 45 degrees adjacent over hypotenuse, it's also 1 over root 2, and nice and easy, the tan of 45 degrees is a beauty because it's just 1 over 1, opposite over adjacent, so it's just 1, nice and easy. Okay, if we take them from this one here, we need to mark up the sides. Now for convenience, I'm going to go, the hypotenuse is 2 this time, because that allows me to go this adjacent side to the angle of 60. I can now call that 1. Okay, and again by Pythagoras, now this time this is the hypotenuse, so that squared take away that squared would give you 4 take away 1 is 3, so that would be the square root of 3. Okay, so now we can quickly get these in, and we can say that the sine of 30, okay, is opposite over hypotenuse, is a half. The sine of 60 is opposite over hypotenuse, so it's root 3 over 2. The cos, that will be root 3 over 2, adjacent over hypotenuse. Adjacent, where am I? Oh yeah, the cos of 30 is adjacent side, which is root 3 over hypotenuse is 2, and the sine of the cos of 60, sorry, is adjacent over hypotenuse, which is a half. And then tan, the tan of 30 degrees, opposite over adjacent, so unrationalised 1 over root 3. Okay, and the tan of 60 is opposite over adjacent, which is root 3 over 1, which of course is just root 3. So there we have it. Now when I was your age, I learnt all of these off by heart. Okay, so it's a good thing to do because you use these values a lot. When they're setting questions in the textbook and on the exams, okay, then they could use any angle that they want. They can use any angle that they want, but they often just use these angles, 30, 60 and 45. So you can just quickly, without going to your calculator, just use these values here. And it's just for ease and sort of quickness. So as long as you understand the skills involved, they set a lot of questions involving just 30 degrees, 60 degrees and 45 degrees. They're very sort of common angles. Okay, so you can learn those. I sort of struggle a bit, so sometimes I forget them. You know, I'm old now, I'm 53. Sue's how old am I? Am I 52 now? So I'm getting a little bit old and I sometimes forget them, and you know, I have to draw the triangles, you know, again to remember them. Okay, so yeah, just also remember as you start the exercise to practice those for 10b, just remind you, let's just apply that to the cast wheel. Let's go with the sine of 60 degrees here. Okay, so if I just rub that out and then just look at the cast wheel with this, okay, there you go, get all of that out and look at the sine of 60 degrees. Of course, when we look at the cast wheel, okay, there's our cos, all, sine and tan. Okay, so cos, all, sine and tan, cast. And when we look at 60 degrees, there's our naught. We go around this way, don't we? 90, 180 and 270 and 360. I almost put 360 there. Okay, when we look at 60 degrees, of course, it's not just 60 degrees, is it? Okay, there's 60 degrees, but 60 degrees is 60 degrees in every quadrant. So if we turn back 60 degrees here, we're back to 120 degrees. If we turn 60 degrees in here, it's 240. If we turn 60 degrees back into here, of course, it's 300 degrees. So when we talk about the sine of 60, we're also talking about the sine of 120, of the sine of 240, and the sine of 300. So if you're asked to find the sine of any of these, okay, well, the sine of 60 degrees, of course, is opposite over hypotenuse. It's root 3 over 2, okay? So that means I'll choose a different colour because I can. Today's colours are sponsored by Sabia. Okay, you know, this is going to be root 3 over 2, isn't it? And if we look at our cast wheel, that's where they're all positive. So it's positive, root 3 over 2. But you can see that 120 is in the region where sine is positive. So that is also root 3 over 2. Okay, 240 is the same as 60 degrees, that's root 3 over 2 as well, but because it's in this region, only tan is positive, so you put sine of 240 into your calculator, you're going to get minus root 3 over 2. Same value, but the negative value of it. And likewise with 300, that is going to be minus root 3 over 2. Okay? So let me just explain that again. If I change the sine to cos, I'll give you another example. Okay, the cos of 60 degrees is a half. So the cos of all of these is going to be a half. I change them all to a half now. The cos of all of these are going to be a half. Okay, these angles. But cos is positive in these two regions. So for them all and for cos. So 60 and 300. So 60 and 300 are going to be positive. Okay, and 120 and 240, you put them into your calculator, you're going to get minus a half. And that's how the cast wheel works. Okay, and 10b, just to start you off, okay, 10b, and they're all the same, okay. First question says the sine of 135, and it wants an exact value for the sine of 135, okay. And again from the cast wheel, 135 is into this region here, 0, 90, 180, there's 135 degrees. If you turn there, what angle is that really? Okay, well my brain doesn't think of it as 135. My brain automatically works out that angle, which of course is 45 degrees. Okay, and C, A, S, T. So we'll look at that. It's in this region here. It's actually the same angle as 45 degrees. The sine of 45 degrees is equal to, well, there it is, opposite over hypotenuse, so 1 over root 2. So this is 1 over root 2. And now I just have to decide, is it positive or negative? Well, look what region it's in. It's in the positive region, so it is plus 1 over root 2. Okay, and that's today's lesson. So make sure you can do exercise 10b. Stay safe out there, okay, and have a good day. Okay, thank you.